Have you ever wondered if time, as we understand it, is truly linear and unchanging? It's a fascinating question, isn't it? We perceive time as a constant, a steady tick-tock that structures our lives from the moment we wake until we fall asleep. We measure our existence in years, months, days, hours, minutes, and seconds. But what if our understanding of time is not as straightforward as we think? Imagine for a moment that time is not a straight line but a river. It ebbs and flows, speeds up and slows down, influenced by forces we cannot see. Picture a leaf floating on this river of time, carried along by the current. That leaf is us, humanity, moving through time. Now let's delve deeper. What if a force, like a wormhole, could influence this river of time? Wormholes, theoretical passages through space-time, have been a staple of science fiction for decades. But what if they aren't just fiction? What if a wormhole could actually cause time to move faster? Consider this. If a wormhole's gravitational pull could distort space, could it not also distort time? After all, Albert Einstein's theory of relativity tells us that space and time are intrinsically linked, forming a four-dimensional space-time fabric that can be warped and twisted. So if space can be distorted, then it stands to reason that time can be too. This isn't just idle speculation. Some scientists believe that time is indeed accelerating, though the evidence is still under scrutiny. The consequences, however, could be monumental. If time is moving faster, then our perception of reality could be fundamentally altered. This brings us to a sobering question. If time is indeed accelerating, what might this mean for humanity? We've all heard of wormholes, but do we really understand what they are? Let's take a moment to delve into the depths of this cosmic enigma. Wormholes, also known as Einstein-Rosen bridges, are theoretical passages through space-time, predicted by the theory of general relativity. Picture a tunnel with two ends, each at separate points in space-time. This could mean different locations in the universe, different points in time, or even different universes altogether. Imagine, if you will, a cosmic shortcut, a way to traverse vast distances of space or time in just the blink of an eye. But hold on to your hats, folks, because this is where it gets really interesting. You see, wormholes aren't just cosmic shortcuts. They're also potential time machines. Theoretical physicist Kip Thorne proposed that if one could keep a wormhole open, and then move its ends to different points in time, you could literally walk through one and emerge in the past or future. Sounds like the stuff of science fiction, right? But it's not as far-fetched as you might think. Albert Einstein's equations of general relativity, which have been tested and proven time and time again, allow for the existence of wormholes. However, there's a catch. Theoretical wormholes would be extremely unstable and would likely collapse instantly unless they're sustained by a substance known as exotic matter, which is believed to have negative energy density and a large negative pressure. So where does that leave us? We've got a theoretical cosmic shortcut that could potentially warp time, but we'd need a substance that may or may not exist to keep it open. It's a tantalizing prospect, and scientists are actively researching and debating these concepts even as we speak. So, if wormholes can distort time, could one be responsible for time speeding up? That's the million-dollar question, and one that we'll delve deeper into in the next scene. Strap in, because this journey is just beginning. Now that we've grasped wormholes, let's delve into another intriguing concept: time dilation. Imagine this. You're on a spaceship zooming near the speed of light while your best friend is back on Earth. You both have clocks. To you, your clock seems to be ticking normally, but when you glance at your friend's clock through a powerful telescope, it appears to be racing ahead. This, my friends, is time dilation. The idea that time can stretch or shrink based on relative velocity or gravitational forces. Let's break it down. According to Einstein's theory of relativity, time is not a constant. It's a flexible, malleable dimension that reacts to the forces acting upon it. The stronger the gravitational field or the faster the speed, the slower time moves. This isn't just theoretical, it's been proven by precise experiments. For instance, atomic clocks flown in jets have shown slower time compared to those left stationary on Earth. Now let's tie this back to wormholes. If wormholes exist and if we could travel through them at high speeds or in areas of strong gravity, we could theoretically experience significant time dilation. A journey that feels like mere minutes to the traveler could span years, decades, or even centuries in the outside world. This isn't just the stuff of science fiction. The GPS system that guides you to your favorite coffee shop relies on the principles of time dilation. The clocks on GPS satellites tick faster than clocks on Earth due to the weaker gravity and higher speed, and adjustments have to be made to keep your GPS accurate. So, what does this mean for us? Well, if we could harness the power of wormholes and time dilation, we could potentially travel vast distances in the blink of an eye, or even manipulate time itself. But, as with all great power, comes great responsibility. Time dilation and wormholes aren't just fascinating scientific concepts, they're potential game changers. They could redefine our understanding of the universe and our place within it. With time dilation and wormholes in play, the implications for our understanding of time are far-reaching. Imagine if time is indeed moving faster. What might be the implications for us and our world? Let's start by considering the biological implications. If time is accelerating, then our perception of aging could drastically change. We may age faster, our lifespans could shrink, and the entire human life cycle could be condensed. This would put pressure on us to accomplish our life's goals in a considerably shorter amount of time. It's quite a sobering thought, isn't it? Then we have the technological implications. In a world where time moves faster, technology would likely evolve at an unprecedented pace. We'd see cutting-edge technologies emerging and becoming obsolete within the blink of an eye. The rapid pace of technological advancement could either lead us to a future of unimaginable progress, or, paradoxically, to a new dark age. If we're unable to keep up with the pace of change, we risk being left behind, unable to understand or control the very technologies we've created. Finally, let's consider the societal implications. A world where time moves faster would also mean that societal changes happen more rapidly. Social norms, political ideologies, and cultural values could shift in what feels like an instant. It might be a world of constant flux, where the only certainty is uncertainty. The rapid pace of change could also lead to instability and conflict as societies struggle to adapt. But it's not all doom and gloom. A faster-moving world could also bring about new opportunities for growth and innovation. It could push us to become more efficient, more adaptable, and more resilient. It could force us to rethink our approach to life and society, encouraging us to embrace change rather than resist it. The possibility of accelerated time presents us with both thrilling and daunting prospects. So, as we grapple with this concept, let's remember, the future is not set in stone. It's up to us how we choose to navigate the challenges and opportunities that lie ahead. Could accelerated time signal the end of humanity or the beginning of a new era? This is where the rubber meets the road, where theory and speculation collide with the stark reality of our existence. The acceleration of time, a concept once confined to the realm of science fiction, is now a tangible prospect, thanks to the enigmatic properties of wormholes. But what does this mean for us, for humanity? If time is indeed accelerating, we could be barreling towards an apocalyptic scenario. The laws of physics as we know them may begin to unravel. Gravity could intensify, crushing us under its weight. The speed of light might no longer be a cosmic speed limit, rendering our world unrecognizable. We could witness the collapse of everything we hold dear, from our physical bodies to the societal structures we've built over millennia. It could be the end of humanity as we know it. But let's not surrender to despair just yet. Every coin has two sides, and this one is no exception. The acceleration of time could also signal the dawning of a new era, one filled with unimaginable scientific and technological breakthroughs. If we can harness the power of wormholes, we could master time travel, journey to distant galaxies, and unlock secrets of the universe that have eluded us for centuries. We might even discover new dimensions of existence, expanding our understanding of reality beyond the three dimensions we currently inhabit. These possibilities are both exhilarating and terrifying. They challenge our understanding of the universe and our place within it. They force us to confront our deepest fears and dare us to dream bigger than we ever thought possible. Yet regardless of the outcome, one thing remains certain: our fascination with time is unending. Whether it's an end or a new beginning, the mysteries of time continue to captivate us, pushing us to explore, understand, and perhaps one day, control the very fabric of our existence.